today's video, we're going to be looking at something called the carbon cycle. Carbon is in a lot of things, and it's essential for life on Earth. In fact, the carbon that's on Earth today has actually been here for a very long time. This includes the carbon that's in our atmosphere. Kind of like with the rock cycle, carbon is always being recycled on Earth and finding its way through the different spheres on Earth: the atmosphere, the hydrosphere, the biosphere, and the lithosphere. But in order to cycle through those spheres, it has to go through certain chemical processes and changes. Here's what NOAA has to say about it.
What is the carbon cycle? Carbon is the chemical backbone of all life on Earth. All of the carbon we currently have on Earth is the same amount we have always had. When new life is formed, carbon forms key molecules like protein and DNA. It's also found in our atmosphere in the form of carbon dioxide, or CO2. The carbon cycle is nature's way of reusing carbon atoms, which travel from the atmosphere into organisms in the Earth and then back into the atmosphere, over and over again. Most carbon is stored in rocks and sediments, while the rest is stored in the ocean, atmosphere, and living organisms. These are the reservoirs or sinks through which carbon cycles. The ocean is a giant carbon sink that absorbs carbon. Marine organisms, from marsh plants to fish, from seaweed to birds, also produce carbon through living and dying. Sometimes dead organisms become fossil fuels that go through combustion, giving off CO2, and the cycle continues.
I want you to find this page in your notes entitled The Carbon Cycle. While we're filling out the notes, I want you to follow along on the diagram that's in the middle of the page. So for the carbon cycle, let's say when carbon is exchanged between different parts of the Earth. Carbon is stored in these things called reservoirs, or places that hold carbon, and move between them. See notes below. So the specific processes that have carbon moving between those reservoirs, they're listed below the diagram. I already wrote them out in your notes for you. You're welcome. We'll go over those in just a second. Reservoirs, then, are the things in this cycle that actually store the carbon. So things like the atmosphere, coal, oil, and natural gas that's inside the Earth. The deep ocean can do it. Organic matter, vegetation. They all have carbon in them, so carbon is stored there. The ways that carbon moves between those reservoirs are called flux mechanisms. So now we're talking about things like photosynthesis, burning of fossil fuels, and respiration. So it's natural for carbon to move through the cycle. It takes a very long time, though. What we're seeing today is that there are imbalances that are being created in this carbon cycle, and carbon that's been stored underground for a long time is now finding its way into the atmosphere.
Throughout Earth's history, carbon has cycled naturally between the ocean, the biosphere, and the atmosphere. This continual cycle regulates the amount of carbon dioxide in the atmosphere. For the past few 100,000 years, the natural carbon cycle has been in balance, keeping the concentration of atmospheric CO2 more or less constant. But with the Industrial Revolution, humans began to dig up and burn huge amounts of fossil fuels. This long-buried carbon that would have taken millions of years to enter the atmosphere is now being suddenly released in a geological instant. Together with deforestation, this has upset the natural balance of the carbon cycle. Over the past 150 years, the concentration of atmospheric CO2 has risen from 270 to 400 parts per million. The higher this concentration gets, the greater the greenhouse effect becomes. As a result, the planet is warming, and the Earth's surface and the ocean are heating up. This is already causing our climate to change. Unless we rapidly reduce our carbon emissions, we risk seeing more extreme weather events and other dangerous impacts in the years to come.
So the changes that we're seeing in climate today are largely a result of changes in the carbon cycle. Carbon that's been stored for millions of years underground in fossil fuels is now entering the atmosphere when fossil fuels are burned. More carbon accumulates in the atmosphere and can't be removed quickly by other natural processes, making Earth's atmosphere warmer. Now add deforestation to that. One of the natural ways that carbon is taken out through photosynthesis now isn't happening as much because we don't have as many forests as we used to. So there's a lot more carbon in the atmosphere than there used to be, and it's not natural. Now if you look at your notes below the diagram, you'll see that this has all been summed up for you already. Now how do we know this? Well, it's actually been studied at length. If you look at the next page of your notes, you'll see a lot of information from NASA. I want you to take a close look at the graph. Now we've already seen that it's natural for carbon dioxide levels to rise and fall within the atmosphere, but where we are today is much higher than it's been in the last several 100,000 years. In fact, the last part that I've highlighted for you is indicating a very steep increase in greenhouse gases since 1950. This is called the Keeling curve. So the Keeling curve is showing direct measurements of carbon dioxide from the atmosphere going all the way back to 1958, and it's still being done today. And they are showing that yes, even though there are seasonal variations in the amount of carbon dioxide, it has consistently increased from year to year ever since they started measuring it.